I wanted to do a problem today in class, but I ran out of time. But then I was looking at the homework and I realized maybe it was something that I could show you, just some hints here. What I'm doing here is on page 65 in the course pack, I'm taking the bus waiting time example. And what we have is x1 is uniformly distributed on 0 to 5. So if we look at that, then x would go from 0 to 5. And if we figure out the uniform distribution, that means that f of x equals 1/5 from 0 to 5. You could put less than or equals 2 or not. So from what we know from earlier, the mean is 0 plus 5 over 2, or 2.5. And it turns out that the variance is 5 minus 0 squared over 12, or 25/12. You can find this out on another one of your homeworks. But let's kind of talk about what happens when we have x1 uniformly distributed and x2 uniformly distributed. What we have is our domain will be a square going from 0 to 5 on x and 0 to 5 on y. And let's sort of set this up where we could find out the CDF of this distribution. Okay, so instead of x bar, what I'm going to do is have this random variable as y is going to be equal to x1 plus x2. I should really divide by x bar, but I won't for this. So the PDF for this one, for f of x1, x2, will now be this area, or 1 over 25 will be the area for this. And so we want to write out what's the PDF for x1 plus x2. All right, so let's go ahead and calculate this. I'm going to go switch to another sheet of paper here. Okay, so there are two parts that we saw in the book. One is on page 143, and this is the one that we get from here. And then also found on page 151, number 20, which I think is also a homework assignment from section 5.1, where you get this right here, which is the exact same thing for the total waiting time. So what we want to do is sketch the CDF of y, or maybe you will want to sketch the CDF of y. So let's kind of go through just some ways that you can look at it then. So here's my domain. And if I wanted like x plus y is equal to 1, let's say I wanted to find the probability of x plus y is less than or equal to 1, well, what that would mean is that the line would have to go through the point 1, 0, and 0, 1. So the area, or the volume in this case, would be the area of the triangle, 1/2 times 1 times 1, times 125, which is the PDF, which will give me 1/50th. If I wanted to find the probability of x plus y is less than or equal to 3, then I could have the points 3, 0 and the point 0, 3. Find the area of this rectangle, or sorry, triangle, 1/2 times 3 times 3 times the probability density function, and that gives me 9/50ths. So in general, if I want to find the probability of x plus y is less than or equal to this tau, I'm going to have 1/2 tau times 1 over 25, or tau squared over 50, as long as tau is between 0 and 5. It's a little bit of a different story when I go up to something bigger than 5. So let's suppose that I go up here and I want to find the probability that x plus y is less than or equal to 8. Well, if I have this case, now, well, since x plus y is 8, this point has to be 5,3, and this has to be 0.35. And so what I could do is I could figure out the 1 minus that area up there. So this will be 1 minus the area, which will be 2 more up to this, so 1/2 2 squared times the PDF 125. That will give me 1 minus 4 over 50, or 51/50ths. If I wanted to find the probability of x plus y is less than or equal to 10, well, that would just be 1 minus 0 because there's no area there. And if I wanted to find the probability that x plus y is less than or equal to tau, well, if I have a tau here, what I'm going to have is these two numbers added to 8 and then subtract it from 10. So the area of the triangle will be 1/2 10 minus tau times 10 minus tau times 1 over 25th, and then I need to subtract that from 1. So again, the idea is if this is 8, the length of this triangle will be 3. 5 minus 3 or 2. Times 2 gives me 4. And if this were 6, then 10 minus 6 gives me 4. 4 times 4 gives me 16 times 1/2. And if it's tau, I'm going to take 10 minus tau, and that will give me the bases of my isosceles right triangle. So now notice if I then multiply this out, except for this is supposed to be a minus and that's supposed to be a plus 1. So 1 minus 1/50th 10 minus tau squared. And so this will give you my CDF, then, that the probability of my variable that I had earlier of y, actually can't remember what your homework, what variable it worked in your homework, but we could call this g of y would be equal to big Y squared over 50, and then 1 minus 1 over 25, 10 minus y squared. And this is if y is between 0 and 5. This is between y is 0 and 10, depending on where we were on this. On that square. Well, now let's find the PDF. If this is the CDF, then this would be the PDF. G prime of y will be g of y, and the derivative of that will be 1 y over 50. I'm sorry, y over 25, and that's if y is between 0 and 5. And if I take this derivative, well, y will go away. I'll be left with minus 2 over 25, 10 minus y times negative 1, which is the same thing as 10 over 25 minus 2 over 25y. Alright, so I was off the screen. And I think I forgot the 50th part, because 1 over 2 times this should be 50, and 1 over 2 times this should be 50. So this should be over 50, this should be over 50, this should be over 50. And so let's see, 1 over, yeah, the 1 over 25 goes there, 10 minus y squared. When I take minus 1 over 50, that's good. Now when I take the derivative, y over 25, bring this down, I get 2 over 50, 10 minus y, negative 1. So let's start this over again. That would be minus 20 over 50 plus 2y over 50, which is minus 2/5 plus 1 over 25y. And this is if 0 is y is, I'm sorry, 5 is less than or equal to y is less than or equal to 10. So just that little 50 messed me up a little bit, but I calculate this. And now notice what happens if I go to page 143. Voila, that's exactly what we end up getting. So that's our CDF, and from earlier parts what we had was that, well, since I want to know what this random variable is of y equal to x1 plus x2, the expected value of y will be the expected value of x1 plus the expected value of x2, and we found that earlier to be 2.5 plus 2.5, or 5. And also the variance of y, again being this x plus 1 plus x2 of these two uniform distribution, will be the variance of x1 plus the variance of x2 plus some covariance stuff, but since they're independent, this will be 0. And so the variance that we figured out earlier as 5 minus 0 squared over 12 was 25 twelfths plus 25 twelfths, which will give us 50 twelfths. Okay. Now let's kind of connect that back to what we had here. Now I'm not doing x bar, I'm going to just do x1 plus x2 and kind of compare with that with what we get on Minitab. So on Minitab what I'm going to do is I'm just going to put a lot of random data in 2 columns for the uniform distribution, and the number of rows I'm going to generate, let's just do 1,000, 10,000, and we're going to store this in column C1 and C2, and we're going to go from 0 to 5 for our limit. So if I do that, what I do is I get all these different values. I maybe have to wait 4 minutes for the first bus and 2 minutes for the second bus. And for C3, since I just want the sum, actually there's another way I can do this. I can just do the row statistics, and I'm just going to take the sum of C1 and C2, and I'm going to store the result in C3. And if I do that, then I'm going to graph the histogram of this and do this of C3, and we'll see what we get. And what we end up getting is this PDF that looks like the line of of what we had before, which was y equals y over 25, or just kind of a little triangular peak, which should be the equations or the expressions very close to. Now we didn't, we just counted, we didn't make this percentage, but this should be very close to what we got when we had y over 25 and minus 2/5 plus 1 over 25y. That's the downside of that. Now, so this is the kind of the idea that we could do this for more data. So let's kind of go back to calculating this part. Let's go ahead and make some random data from the uniform distribution. And let's suppose we'll make 10,000, and we're going to store this in columns C4, C5, and C6. Actually, let's do a whole nother worksheet, because so again, we're going to make some random data from the uniform distribution. 10,000 is going to store in column C1, C2, and C3 this time, the lower endpoint. And then what I'm going to do is I'm going to do some row statistics, and this time I'm going to do the mean of my input variables C1, C2, and C3. And we just want to see what the graph will look like if I do the mean. Now the other one I could, except for I stored it in, let's try that again. Okay, and then some new data, and then I'm going to do some row statistics of the mean, and I'm going to store this in C4. And we just want to see what our histogram is going to look like if we take the sum of 3, because that will be closely related to the average. And in this case, we don't get a straight up and down. No, that's our uniform distribution, which we get. Sometimes making these videos, this is the sum of all 3 of them, and again, you're kind of getting more of a curve. And actually, if we did this more and more and took the average or the sum of more and more variables of the uniform distribution, we would get something closer and closer to the uniform distribution. Anyway, I hope that helps you on the homework and also helps you as we go with the sampling distributions going forward.